All right. 11.3, using data displays. Now you don't have to make them today, the displays. We've been doing that. Making, what was the first day? We made what? The very first ones we learned were the stem and leaf. Then we learned how to make a frequency table. What do you make? You have to have a frequency table to make a histogram. Excellent. Now today we're going to talk about all that data. And there's two types of data that we're going to talk about. We have categorical data and numerical data. And it's pretty obvious what each one is. I mean, categorical, categories, duh. Well, we're talking about data that consists of non-numerical values, meaning like colors, names, types of animals, all right? When you're talking numerical data, well, that's just what it says it is. It consists of numbers, numerical. Yep, sales prices, money, gallons. Now, when you wrote these in, it says when you choose a data display, one factor you should consider is whether the data are categorical or is it numerical. And we filled these in, and it says you should always use, you could use a line graph to display numerical data that change over time. So the big thing here, the hint here is anything that changes over time. If it changes over time, you want to use a line graph. The next numerical, use a scatter plot to see trends that are paired. That's your hint there. Trends in pairs. You should squiggly line those too so it's easy to look back at and find the hints. Then, if you have categories, you're going to want to use a bar graph to compare categorical data. And notice out of this whole list, there's only two of them that you use for categories, and that's the bar graph here and a circle graph. Those are the only two kind of graphs you're going to use for categories. You're not going to use those if you have number data. All right, you can, and then the circle graph, the biggest difference between the bar graph and the circle graph is the circle graph presents parts of a whole, meaning we're working with 100%. Add that little hint. Then down here for another numerical, use a stem and leaf plot to organize numerical data based on their digits. And that is your hint there if you're working with digits. You want to use stem and leaf. Use a histogram to compare the frequencies of numerical data that fall in equal intervals. Here you have two hints. You have frequencies and equal intervals. Those are your hints there to use a histogram. And the last one, use a box and whisker plot to organize numerical data into 4 groups. Now don't let this one get confused with the 100% up here, the circle graph. That's categories. The 4 groups, meaning that's 100% also, you know, or 75%, 50%, 25%. Those are in quarters, into 4 groups. Let's practice. Choosing appropriate data display. The table shows the results of a survey that asks consumers to name the day of the week they usually shop for groceries. How many in here have a certain day of the week that your family shops for groceries? How many of your parents or whatever just, when you need something, you go to the store? Yep, that's our house too. All right, well, this survey asks consumers the day of the week that they usually shop for groceries. Which displayer displays, because you can always use one for sure, maybe there's more than one, maybe 2 or 3 you could pick from, but there's always one that's better than the others. What can we use? Looking over here, when consumers shop, Sunday 16%, Monday 12%, and so on. If I add up all of these, what does that equal? What does it equal? 100%. All right? Out of 100%. So these responses to the survey consist of the days of the week, which are what kind of data? Numerical or categorical? Days of the week, what would that be? Categorical. Alright? So therefore, we already did this next one. Also, the sums of the days add up to what? We already did that. So you could use what? If it's categorical, you're going to need your note page out today. Go back to that page we just did. And we just numbered and labeled everything. There's only 2 of them that are possible for categorical. What are they? Oops. So there's only 2. We can use a circle graph or a bar graph. Let's take a vote. So those are the 2 you could use. Which one would be the better one? Would there be one better than the other here? Who would rather have a circle graph in this one? Who would rather have a bar graph? A few more of you are with the bar graph. See, in that case, either one of them, that one's pretty hard to tell the difference. I would take either one in that case. But when you're dealing with 100%, a lot of the times, what are you going to do if it's dealing with 100%? Yep, this one I would do a circle graph with, since we have 100%. So those are the 2 that you could use, but in my mind, this probably would be your better one. How about this one? The table shows the voting age, population, and the number who voted in 10 recent federal elections. Both numbers are given in millions. Which display or displays can you use to display the data? First of all, is it numerical or is it categorical data? We know that it's numerical, so we write that. So now that it's numerical, we know that our choices cannot include what? Bar graph or circle graph. Good job. So looking at our numerical choices, what do we have here? We have the voting age here in millions, and that's paired up with our voter turnout in millions. What could be the best choice here? Out of all those numerical choices on your notes, look back here. What was the hint? What kind of data do we have? We know it's numerical, but we look at here. Does it give us a change over time? No, so we're not going to want to use a line graph. How about here? Do we see trends that are paired? Well, let's look over here. Don't we have paired data in population in millions and the voter turnout? Do we have a pair of data here? So what would probably be our best one then? The scatter plot. Okay, so it is numerical, and scatter plot would be our best bet. How about here? Weekly grocery expenses. An economist uses a histogram and a box and whisker plot to display the average weekly grocery expenses of 30 consumers. What are the advantages of each display? Well, let's look at letter A. Looking at the what graph? Letter A is which one? What do we call this one? The histogram. The bar graph using the histogram. All right? They ask us, using the histogram, the economist can compare the number of what in each interval? Here's our intervals. These are our frequencies. They're missing their title. Mrs. Lennon would give them one wrong. Should be weekly expenses. All right? What does it compare? What do the intervals compare? What are my intervals? Name them. Can compare the number of what in each interval? Oh, I wrote that backwards, you guys. Didn't even catch me. I didn't even do it on purpose. Frequencies go here. Thank you. Frequencies are intervals here. Okay, so what can we compare? The number of what in each interval? The number of consumers in each interval. We can compare. So how many consumers were in the 50 to 59 interval? 50 to 59 right here, and that goes over about right there, so you would be correct. And so we just answered this one. For example, the economist can see that the average weekly grocery expense for 5 of the consumers, right here you said, which is 5, is what to what?
50.
Yep, 50 to 59. Well, the average weekly grocery expenses for blank of the customers is what is 30 to 39? What is this? 10. Excellent. Reading data. All right, let's go to the box and whisker. Using the box and whisker plot, the economist can easily divide the average weekly grocery expenses into low, middle, and high groups of approximately equal size. Equal sizes of approximately what? What percents do we go by in the box and whiskers? Yes, 25%. So knowing that, for example, the economist can conclude that about what percent of the consumers spend $32 or less a week on groceries? $32 or less. What percentage is that?
25.
That's 25%. How about what percent spend from 32 to 45? Now we have 32 to 45. What percent is that?
50%.
50%, because that contains the whole box. So 50%. This one. Identifying misleading data that displays. And there's a question on your test or quiz, and we're both, can't remember which, but it asks you, give me, if you remember, it's 2 or 3 ways on how a graph can be misleading. So you're going to want to take good notes on this part. 2 or 3 ways that graphs can be misleading. If you look at this, the bar graph displays a household's their monthly electric bill from September to February. What is misleading about this display? The number one biggest thing that you can see right there is what? That what? That crack, this zigzaggy thing right here, right there. We call that a broken vertical axis. Anytime you see a broken vertical axis, say you get older and somebody's trying to sell you some insurance or some sort of annuities or plans or whatever, and they're ever trying to sell you something and show you something, and they ever show you graphs that have a broken vertical graph, toss them out the window, because they're so misleading and they're going to try to make you believe something that's really not as good as it is. So that's the number one thing you want to look for, is the broken vertical axis. That's number one way a graph can be misleading. What's another way that a graph could be misleading? Anything else that you could think of? Well, let's finish this one out, and then we'll come back to it, because there are a couple more that you'll have to know for your test. But let's figure this one out. Number one, the broken vertical axis, it exaggerates the differences in the bar lengths. For instance, it appears that February's electric bill is, well, if you look at February, just if you don't look at the numbers over here, you look at February, look at this one right here. We fill that in. And then we fill in What do they say? February's electric bill is how many times that of October? So by looking at the graph, the way they have it, how many Octobers would I have to take to fill up this February? I'd take about what? Looks like it would take about 3 of these. Just 2 bars, right? 2, 1, 2, 3. 1, 2, 3. Looks like it takes 3 of Octobers, doesn't it, to make a February. So just by looking at that graph, it looks like February's electric bill was 3 times bigger than October's. So that means if October's was $100, they're saying that February would be $300. That's the way that graph makes it look. In actuality, how much bigger is it? How big is October's? $50. And what is February's? $70 is all. So actually it's only how much bigger? What is 70 divided by 50 on your calculators? 1.4. So 70 to 50 equals, it's actually only 1.4 times larger. So it's very misleading. So number 1, broken vertical axis. Thinking of other instances like pie chart or pie graph or circle graphs, we used to call them pie charts. Circle graphs, bar graphs. What are some other things maybe you could think of that would make graphs misleading?
Also bar graphs if they do not do equivalent intervals.
Excellent. That's usually the hardest one to come up with, and you got it right away. You nailed it. All right. The number 2, another one would be what do you want to say? Unequal intervals. You go by 2, 2, 2, and then 3, and then 4, then 2. If your intervals are not equal, that is another misleading. Another one, relating maybe to circle graphs. What could be misleading on the circle graphs? Not a total of 100%, or you've all made circle graphs in math and science. What's another thing that can happen when you're making it? The what? Crooked. Okay, or your, go with that, work with that. She's on, you guys are on the right track. If you have a circle graph and maybe this might be 2%, this might be 50%. Does that look like 50% of my graph? No? So maybe, what could we say? How could you say that about a circle graph? Percentages are off. What do you want to say? So you remember it. How do you want to word it? Percentages are off? Make sure the graph matches the percentages? Okay. Third one could be graph doesn't match percentages. Excellent. All right, and like I said, you're going to need to know those for a test, so keep that in mind.